1. Does the demonstration showcase the implementation of the program designed for your program using SQL? So in this program, as you can see in line 17, we have a database file, and this is a string that stores an SQL statement for creating tables for a worlds table, and this SQL statement is for creating a table for storing obstacles. And here we have statement.execute. We are executing the SQL statements, so that just shows that our program is using SQL. And we also have the world data access interface, which uses SQL. And so here's some SQL queries, and also here more SQL queries for working with the obstacle data access interface. Question 2. Does the demonstration showcase SQL code that is understandable? So for world data objects, you have these understandable. So this SQL is fairly understandable. For example, here, if someone might find the SQL query difficult, although it is rather simple, you could also look at the name of the method. It will also guide you. So it's select all from worlds with the ID. So it fetches you, it gets you a world from the database based on the ID. Select all from worlds with name. So this one gets the world by name. Select all from worlds. It gets all the worlds. Insert into world name size. So this one, you insert a world into the world table. Update world. This one changes certain properties of the world, so it could be the name, the size, and the ID of that world. And this one deletes a world based on the ID. So all the SQL statements are fairly understandable. They're pretty simple. Question 3. Does the demonstration showcase the use of SQL functionality that optimizes queries? So SQL functionality in this case, which optimizes queries, is the existence of these annotations. These annotations provide metadata about the code and are used to give instructions to the compiler, runtime, or other tools. These annotations are used to directly map SQL queries to Java methods, allowing for a clean and efficient way to interact with the database. So we use these annotations to optimize our queries. Question 4. Does the demonstration showcase SQL functionality that makes SQL code understandable? So these annotations are not only for optimizing our code, for making it more efficient, but they also help with readability, as we've sort of separated our code from the SQL queries stand on their own, which makes them more readable, and so they are not like mixed in with our code. And also you have the method names also guide you as to what those SQL statements mean. Does the demonstration showcase the necessity of each join SQL query? So in this program we didn't use the join SQL query anywhere. So the demonstration showcased the use of SQL functionality that prevents integrity of data accessed by multiple users and processes. So with our database, only one client at a time. So database access is it isn't threaded, so only one client can make changes to our database at a time, and also the database management systems handle that. Does the demonstration identify methods of accessing data for your program? So methods that access data, for example, it would be restore world. So restore world will restore a particular world from our data, from our database, given the name. So the user provides the name, and then the restore world will then go to our database and then get that world. So for example, here we have first line 146 prompts the user for the name that they want, and on line 155 we are then using our data access object. So data access object got world by name. We could look at that. Query, here is the query which we looked at before. So select all worlds where the name matches our given name. So that allows us to get a particular world. So that is one example of data access. Another way of the program accesses data from the database is by using the another way that our program accesses data is through the API. So the API, someone will send a GET request with a world name, then the API sends that request or the information about that request to our data access objects, and then that data access object would then call the aforementioned restore method, which takes in a world name. So that's one way in which, those are the two ways in which data is accessed in our program. Does the demonstration showcase good use of data sharing within the application? So data sharing within the application, one example of this is when you're creating a robot. So you have this robot constructor, it creates a robot, and then one method on line 61, it builds a robot. So based on the type, so a robot will have a certain number for the shield and the max shots, but then that depends on the type of robot, right? So based on the type of robot, if it's a shooter, we will then get the appropriate value from the shooter class for the max shields, and also from the max from the shooter class for max shots, so and so on and so forth. So this demonstrates data like sharing. So that's one sense in which classes are sharing data between themselves. And another way is when the server, sometimes it is asked to, when it gets the robots command, it is then asked to list all the robots. It will then have to access a list of all the robots, and that list, as we can see on line 183, is declared as so as we can see, the list of robots is stored on simple server on a list called robot objects, and the display headers class has to access that list. And also when the API has to add a robot, looking at API handler, when an API has to launch a robot, it will launched, it will also use the same, it will also add on, as we can see on line 45, a robot name, or line 46, a robot object will be added to the robot objects class. So that is another instance of data sharing data in our project. Does the demonstration showcase the underlying technologies that link databases and websites? So one of the technologies that is used to link databases and websites would be what we can see on line 27, Javelin. So in this case we are using Javelin for our API server, and that can be used to connect a website with a database. So the Javelin server is responsible for receiving HTTP requests and then sending back responses. So on line 39, so the server is kind of listening for post, for a post request of that form, and then it will behave appropriately. The behavior is hidden in a robot API handler in a method called launch robot. And then this one doesn't use the database, but get so you have Javelin, which is a technology listening for HTTP requests. Websites can make HTTP requests, so it can be used for that as well. And also you have world. So you have, in this case, so the client, it could be anything that can make a HTTP request. It is asking for a world given a name. Then we will use the restore world method that is found in our data access objects, and that will return the world given the name, and then send that back to the to whoever made that request. Does the demonstration showcase methods linking web pages to back-end proprietary applications? So again, we have Javelin, which can be used to link web pages to proprietary applications. So in this case, our proprietary application is the code that we are running, that is the code we wrote in Java, so all our classes and everything. So Javelin is what would link us to out there via HTTP. Then we get the requests, and then those requests are processed in the Robot World API handler, and then that Robot World API handler is using code from other sections of the Robot Worlds. So Robot Worlds would be our proprietary code in that case. So question 11, does the demonstration showcase code that is commented? So in our database setup, we have comments. So for example, in line 17 we have an inline comment telling us that's the SQLite database file. Line 28 is telling us so we are setting up the database connection. Then we are registering, and line 38 registering the SQLite server, and then these are SQL statements to create tables, and then we execute table creation. So those are examples of comments.